Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so in this lecture, we are going to look at an application of differential equation. Since that the previous video we discussed the method of application of differential equation, which is separable variables and integrating factor. It's time now for us to find out where that we use in our daily life. Okay, so the beginning of this topic, beginning of this lecture, we will look at the application of differential equation. Okay, so in this case, we are going to solve the problems involving the first order differential equations, such as Newton's law of cooling, electric circuits, population of growth, radioactive decay, and many more. But these are few examples that are related to differential equation. Okay, so step in solving the differential equation. Define the variable with x with a variable of t. Write the proportional equation in terms of k. Integrate x with respect to the x. Okay, so the usage of integration. Okay, and substitute when t equal to 0, we need to find out the constant of c. And also when given another t time, we're going to find the constant of k and solve the rest of equation. So let's take a look at example 1 here. The rate of decay for a radioactive substance is proportional to the remaining concentration, which is given by the differential equation of dx dt equal to negative kx. Okay, the rate means that the changes of something respect to the time. Okay, so meaning here we're talking about the changes of the rate of decay of radioactive substance and proportional to remaining concentration, and has something to do with the t or time here. And decay, let's say this is the amount of radioactive substance. Okay, at the beginning we get 1 kilogram of any radioactive substance, and until one period the amount getting less or smaller. It might be 500 grams. So it means that here decay from the beginning of the amount and is getting lesser and lesser, and that's why we come up with a sign of negative here. Okay, so if 1/3 of the substance still remains within 12 years, how many percent of the substance is still available after 3 years? Okay. Meaning here, at the beginning of the experiment, the amount is 1 kilogram, where t equal to 0, then the n, let's say here, which is 1 kilogram. Example only. And then within 12 years, so after t equal to 12, to 12 years, then what is the amount that we get? And also, once we get the constant of k and c, I'll show you later what is the k and c is all about. And then we can find out the percentage is still available after 3 years. So this is it. So when t equal to 0, t equal to 0 is not exactly the time is 0, no. But then it's the beginning of the experiment. So at one date, one time, let's say 1 January of 2 years of 2000, then we bring up this radioactive substance into the lab, and we keep recall the day and the date, and also the amount, the weight of this. And after 12 years, we found that it still remained 1/3 of the earliest of the weight of this. Okay. Okay, so let's say at the beginning of the day, at the date of the experiment, so I bring up we call this radioactive substance into the lab, and then I found that the initial mass means that the earliest of the weight of this is x naught, and then 12 years later, then I found that is 1/3 left of the initial mass that we found at earliest, let's say, for example, here. Okay. So now, let x we put this as a concentration of radioactive at time t. Okay, so then the given here dx dt equal to negative k called kx. Okay, so now in between this sign of equal sign here, if I divide this side is for an x, and on the other side let this recall for the sign of t here. Okay, so we separate the variables. K, negative k is a constant, so we bring up x to the left side, means that we multiply with 1 over x and also multiply with 1 over x dx equal to negative k dt. And now, as recall, we have separate the variables here with x with the dx, and negative k is a constant with the variable of t. Then we begin the integral of left and right. We come up with natural log of x equal to this one also. This we may also write down as negative k integral of dt. Then we come up with negative k d plus c. Then we may simplify this using the Euler's constant of e, then here and also here, then come up with the x equal to e power of negative kt plus c, or e power of negative kt times e to the power of c, and we simplify as an a, e power of negative kt. Okay, make a note that where a equal to e to the power of c. Now, the first information given in the question there, the initial mass of x equal to x naught. X is the what we call the mass or we call the weight of the radioactive mass, and we call radioactive substance here at the time of t equal to 0. Okay, so this is the earliest equation that we get here just now. We substitute x with an x naught equal to a e power of negative k and t equal to 0. So 0 times negative k equal to 0 and e power of 0 equal to 1. 1 multiplied with a equal to x naught. So then here now, look at this one here, where x equal to a equal to x naught, substitute here, replace with a with x naught e to the power of negative k d. Okay, that is the first one. Now, the next question, if 1/3 still remains within 12 years, meaning please refer to your notes again. if 1/3 of the substance still remains within 12 years. So means here, when T equal to 12 and the current mass after 12 years here, it is 1/3 of the initial mass. Okay, where initial mass is the beginning of the weight of the chemical substance here. Okay, now when T equal to 12, X equal to 1/3 of X naught, then we substitute here, where X equal to 1/3 X naught equal to, then here is also X naught e power of negative K and T equal to 12. Okay, divide X naught left and right. We come out with 1/3 equal to e power of negative 12K. Then we come up with a ln left and right, natural log left and right, ln 1/3 equal to natural log with an e, cancelling each other, then you come up with negative 12K. Okay, so at this moment, class, right now, okay, just now we already found that the value of A, where we can replace with the X naught, it's time for us now to find out the value of this K. Okay, so we trying to replace the constant with a value, and then now where K equal to K equal to natural log of 1/3 divided by negative 12. Okay. So class, for this one here, you may use your calculator to find that the K equal to natural log of 1/3 divided by negative 12. So I found it already here, which is K equal to 0.09155 something. So I make in the 3 decimal places here 0.092. Okay, so now from here, X equal to X naught e power of negative 0.092 multiplied with T. So that is our equation right here, right now. Okay. Okay, I rewrite X equal to X naught e power of negative 0.092 with T here. Okay, then the next question is, how many percent of the substance is still available after 3 years? So after 3 years, or T equal to 3. So then here now, X equal to X naught. And what about this one here now? E power of negative 0.092 multiplied with T equal to 3. Okay. I separate recall the calculation of this here. And I'm using the photo math from apps from our smartphone, and I found that the value here is 0.758813. Okay, so substitute here 0.758813. Okay, the question just now here, how many percent of the substance is still available? So after 3 years from the initial amount mass of the chemical substance or the reactive substance, after 3 years, then how many percent left? So in this case, the current mass of X equal to the initial mass of X naught, 0.758813, then multiply with 1, because percentage of the we call the chemical substance left, then it come out with 76% of the initial mass. Okay. Next question. An object is released from rest into water. After t seconds, the velocity Vms power of -1 of the object is given by differential equation of this one here, where g is the constant. Show that this all the question here. Okay. You may refer a question from your lecture notes. I'm not going to read all this one by one. Okay, so then given in the question that dv dt equal to g minus 4v. Again, we separate the variables, and this is the term with the variable of v and the constant of g. So please make the difference. Constant means that it has one value given then, but for variable it can be any value, it can change at any time. Okay, and also we also get the variable of t here, so 1 over g minus 4v dv equal to 1 dt. Okay, so then we integrate left and right. So integral of 1 over ax plus b, or b plus ax, 1 over linear, and it come out with natural log of g minus 4v divided by derivative of g and the variable of 4v here equal to -4. -4 equal to t plus c. Now we are going to eliminate this by multiplying with -4 here, and also multiply with -4 with the t and c. So natural log of g minus 4v equal to -4t minus 4c. Okay, and then come up with the constant of e left and right, so come up with g minus 4v equal to e power of -4t minus 4c, which is e power of -4t times e power of -4c, then it is a e power of -4t. And make a note here where a equal to e power of -4c. E is on a unique value of the constant of E itself, and C is the constant. So we replace with one capital letter of A here. Okay, and then we're trying to come up with the equation of V equal to the FV. Okay, V equal to FT here. So -4V equal to a e power of -4t minus g, 4v equal to g minus a e power of -4t, and v equal to 1 over 4. Okay, 1 over 4 g minus a e power of -4t. Okay. Now, v equal to 1 over 4 g minus e power of -4t. When t equal to 0, given a question in the question then. Okay. Jet released from the rest into water after t seconds derivative. All then. Okay. So when t equal to 0 means that the velocity also equal to 0. V and t. So 0 equal to 1 over 4 g minus a e power of -4 times 0. Negative 4 times 0 equal to 0. E power of 0 equal to 1. 1 over 4 g minus a. Okay, multiply with 4 here and multiply with 4. Still 0 then. So g minus a equal to 0, then g equal to a. So we substitute a with g. Substitute a here with g. Then v equal to 1 over 4 g minus g e power of negative 4 t. We factorize, take out both of g here. 1 over 4 g 1 minus e power of negative 4 t. Actually, that this one, actually I should write down here as a g over 4 1 minus e power of negative 4t. Exactly as you recall, we mentioned in question number 1, question number 1i. Show that v equal to g over 4 times 1 minus e power of negative 4t. There you go. Okay. Then next, question number 2, find the velocity of the object when t approaching to positive infinity. So, when t approaching to positive infinity, so what about v from the question of 2i? Okay, in example 2 then, here, so as t approaching to positive infinity, then e to the power of negative 4t approaching to 0. What was the equation just now? V equal to g over 4. Okay, g over 4 1 minus e power of negative 4t. So when t is getting bigger, e power of negative 4 times, example for 1000. So negative 4 times 1000, negative 1000, means that e power of negative, it is 1 over e something, and when t is getting bigger, then e power of negative 4 approaching to 0. Okay, so then here now, v equal to g over 4 per second. Okay, so this is the graph of t and also v here. Okay, this is g over 4 and this is v equal to g over 4 1 minus e power of negative 4t. Okay, question number 3. Okay, now, show the distance traveled by the object in the first 5 seconds is about 19g divided by 16. Okay, so in this case, v also represent, as I recall, the changes with respect to the time, which is g over 4, 1 minus e power of negative 4t. We take a look at this only. Okay, this one here now. Bring this dt to the right side, so then ds equal to g over 4, 1 minus e power of negative 4t dt. Integrate left and right. Okay, integral sign here, we may put it here, or g over 4 is a constant. Okay, we put it here now. So integral of 1 respect to the x, yes, s itself, and then this one here, g over 4. Okay, this one here, integral of 1 respect to the t, and then minus e power of negative 4t divided by derivative of negative 4t, and I want negative 4 plus c. Okay, so then here now it is g over 4 t negative times negative positive, then e power of negative 4t divided by 4. Okay, so this is a question that we get here just now. And now when t equal to 0, so then when t equal to 0 and s equal to 0, so s and t here. Okay, so when s equal to 0, then g over 4, t also equal to 0, 0 plus e power of negative 4 times 0 equal to 0 divided by 4 plus c. And e power of 0 equal to 1. So means here is g over 4. And 0 plus 1 over 4, which is 1 over 4 plus c. And this is g over 16 plus c. And c equal to negative g divided by 16. Okay. Then next, from the equation of s equal to g over 4, okay, and t plus e power of negative 4t divided by 4 plus with c, where c just now we find it, we already get it then here, we get just now, which is negative g over 16. Okay, so when t equal to 5, the last question on this example here, so what about s? Okay, so then here now, s equal to g over 4, where t equal to 5. 5 plus e power of negative 4 times 5 divided by 4 minus g over 16. Okay, class. For this question here, okay, look at this here now. Separate, if I count the separate here, and I use what we call photomath apps using my phone, then the value for this one here is 5.15288 times 10 to the power of negative 10. So how does this looks like? Power of negative 10. So from here, just imagine that this point move 10 steps backwards here. 0.00000001, 2, 3, 4, 5, 6, 7, 8, 9, 5, 1, 5, 2, 8, 8. Okay. Just assume that it is 0 here. Okay, assume it is 0 here. Just assume it is a 0 because they're too small. And what's left here now? G over 5 times 5g over 4 minus g over 16. So then here now, 4 times 4 times 4 here equal to 16. 5 times 4 equal to 20g minus g, and it is 19 over 16 g. There you go. Okay, so that's the last final question for example 2. Okay, now a community of consists of 1,000 homogeneously mixed individuals. An individual who has just returned from another community has influenza. assume that all susceptible influences spread and rate with direct proportion to the number of n who have it, and to the number of 1000 minus n who have not yet contracted. Mathematically, its differential equation is given here. Okay, this is the equation given in the question here now. Okay, and then what is it just now? dNdt kn minus k, where n is the number of people that contracted influenza after t days with a k given 0.0004. Show that this one here now. Okay, and now dn dt equal to kn multiplied with 1000 minus n. So for this question here, if I divide this into two parts here, so I imagine that if I, on the left side, I put this as a house of n, and this is house of t, with a variable of n, variable of t here. Meaning, okay, take a look at this. This is the one that we're going to bring inside the left side here, come out with 1 over n, 1000 minus n, dn equal to k dt. Okay, so we are separate the variables with n and also dn in k dt here. Then we integrate left and right. So for this part, which I think that we need to do an extra job, especially for this one here. 1 over n 1000 minus n equal to a divided by n plus with b divided by 1000 minus n. Okay, so there are two partial fractions here, one the first and second part here, and both of denominators we are going to equalize or compare with this one here. So then multiply this with 1000 minus n and also 1000 minus n, and this one here multiply with n, this one, and also n here. Now both of these fractions with the denominators are equal with this one here now, so we may compare the numerator where 1 equal to a multiplied with 1000 minus n, 1000 a minus a n plus with b n. Okay, so it means that we are going to add something here with 0 multiplied with n plus 1. Then bn minus an, so b minus a with a variable of n here, and plus 1000 a. So in this case, b minus a equal to 0. b minus a equal to 0. Then b equal to an a. And now 1000 a equal to 1. 1000 a equal to 1, then a equal to 1 over 1000. Sorry. Okay. A equal to 1 over 1000. So then when a is 1 over 1000, then b is equal to a, also 1 over 1000. So meaning here, earliest, this is the partial fraction that we form for this equation, and also b with 1000 minus n. Okay, so now 1 divided by n 1000 minus n equal to a, okay, sorry. Now we found out the value of a, 1 over 1000. So 1 over 1000 n plus with b is also 1 over 1000. 1 over b is 1 over 1000 minus n. So now here, for this one, it is integral of 1 over 1000 n. Okay, look at this. And then plus with 1 over 1000 minus n dn equal to integral of k dt, then you got kt plus c. Okay, 1 over 1000 and also 1 over 1000. Take it outside. 1 over 1000 integral of 1 over n plus with 1 over 1000 minus n. dn equal to kt plus c. So 1 over 1000 integral of 1 over n, natural log of n, plus with this one here now, natural log of 1000 minus n, and derivative of 1000 minus n divided by -1 equal to kt plus c. Okay, so now multiply with 1000 to eliminate this. Multiply 1000 on left and multiply 1000 on right here. Natural log of n plus or negative here. Positive divided by negative minus natural log of 1000 minus n equal to 1000 kt plus 1000 c. And between these two here now, using the logs rule, log a minus log b equal to log a divided by b. So in this case here now is come out with log n divided by 1000 minus n equal to 1000 kt plus 1000 c. If I replace this with a capital letter of c, still a constant, okay, and then come out with a constant of e here and also e here, so e to the power of natural log cancel each other then, so come out with n divided by 1000 minus n equal to e power of 1000 kt plus, okay, multiply with 1000 kt plus c, or e power of capital letter of c here. Okay, so then come out with a e power of 1000 kt, where a equal to e to the power of c. Okay, I rewrite this. N divided by 1000 minus n divided by 1000 minus n equal to a e power of 1000 kt. Okay. Okay, so beginning of the observation, when t equal to 0, when n equal to 1, so just imagine that n equal to 1 here, n equal to 1. 1 divided by 1000 minus 1, 999, equal to a e power of 1000 k, and t equal to 0. E power of 0 equal to 1, then a equal to 1 over 999. So substitute a here. where n divided by 1000 minus n equal to 1 over 999 e power of 1000 k and t. And it mentioned in the question that given that k equal to 0.004, okay, for k equal to 0.0004, so then for k, the constant of k here, is given the question which is 0.0004, so n divided by 1000 minus n equal to 1 over 999 e power of 1000 multiplied with 0.0004, 1000 multiplied with 0.0004 equal to 0.4. Okay, means that here come out with 0.4 and t. Okay, and then the next question given that, if I bring up here, okay, n divided by 1000 minus n equal to 1 over 999 e power of 0.4 and t then, okay, so 999 cross multiplied or multiplied with 999 left and right, then multiply with n here, and also this multiplied with the e power of 0.4 t here. Then we get 999 n equal to, okay, this one here, 1000 minus n e power of 0.4 t. Then 1000 e power of 0.4 t minus n e power of 0.4 t. Okay, so we get n here and we got n here, so bring this term to the left side. 999 negative n e, all this negative bring it here become positive, so plus e power of 0.4 t factorized with n equal to 1000 e power of 0.4 t. Then n equal to 1000 e power of 0.4 t divided by everything here. 1000 e power of negative 0.4 t divided by 999 plus e power of 0.4 t. Okay. Okay, so what can we do here now is we are going to eliminate this and this. We multiply with e power of negative 0.4 t divided by e power of negative 0.4 t. And we come out with e power of 0.4 t, e power of negative 0.4 t, we call conjugate between these two, they come out with 1000 divided by this multiplied with this equal to 1 plus 999 e power of negative 0.4 t. Okay. So next, just now it is n equal to 1000 divided by 1 plus 999 e power of negative 0.4 t. Okay. So they given the question that when t equal to 10, so what is the number of the population that we contract with that influenza? Because the question, this is a story about the population of 1000 individuals that contracted with influenza here. Okay, so when t equal to 0, or when t equal to 10 here, then n equal to 1000 divided by 1 plus 999 e power of negative 0.4 times 10, which is negative 4. Okay, which I think that this one you may refer to your press the calculator and it gives you 51.8 or approximate, because we're talking about the number of population people. People cannot be with the decimal places here, decimal point, so it is 52. Okay, and then when given in here half of the population, how many days will it take until the half of the community? So just now we're talking about consists of 1000 individuals, and then question B, how days will it take until half of the community? So half of 1000 is 500. So now the question of B, when n equal to 500 or half of the 1000, so now put it here, which is 500 equal to 1000 divided by 1 plus 999 e power of negative 4. Okay, class, for this one here now, we are still referring to this. Okay, still referring to that. Okay, so when n is 500, say 1000, 1 plus 99 e power of negative 0.4 t. Okay, so you may press the calculator button again, and you find that the t equal to 17.266, where we can just simply round it, make it round with a 17, which means that it takes 17 days to reach half of the population contracted with influenza. And what about question C? Find the limit. So the question wants us to find the limit of C, find the limit of t approaching to infinity of the equation of n population respect to the time. Okay, so when t approaching to infinity, okay, then look at this one here now. When t is getting bigger, if I take this, okay, e power of negative 0.4 t. So when t is getting bigger, let's say t is 100, 1000, 10,000, and so on. When t is getting bigger, multiply with 0.4 and negative. It gives you 1 over e power of infinity. So 1 over big number, okay, from time to time is getting bigger and bigger. So 1 over big number approaching to 0. Okay, so in this case, we may write down as a e power of negative 0.4 t approaching to 0. So then limit of t approaching to infinity of 1000 divided by 1 plus 999 e power of negative 0.4 t, okay, equal to, because of this, I explained to you just now here, it is approaching to 0. 0 multiplied with 1999, 0 times 999, also make it everything here equal to 0. So now 1000 divided by 1, then it is 1000. Okay, so that's all, guys, girls. I do hope that this lecture helps you, and please do continue your tutorial and pass your questions work from your tutorial book. That's all for today. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.